Welcome to my video about avalanches. Avalanches can be surprising, sublimely beautiful, and deadly. They can sweep trains off their tracks, crush buildings, uproot trees, and bury people. Some avalanches have even covered entire houses with people still inside them. Even though movies and news reports say they strike without warning, most deadly avalanches start when victims trigger them. To understand how avalanches form, you need to understand the properties of snow crystals. Depending on the temperature, humidity, and other atmospheric conditions, snow crystals can have a variety of shapes, but are all generally hexagonal or six-pointed. In areas that get a lot of snow, the snow on the ground forms a snowpack. The layers within the snowpack have different qualities due to the shapes of the crystals in the layer. For example, six-pointed crystals can interlock more easily than needle-shaped crystals, so they create a steadier layer. On the other hand, when supercooled water comes into contact with snow crystals in the air, it creates rime. Heavy rime deposits can cause pellet-like snow called graupel, which creates a very unstable layer. Snowpack layers can also have different qualities because of changes that take place once the snow is on the ground. Changes in the weather lead to changes on the snowpack surface. If the top of the snowpack melts and refreezes, it can form a layer of slick ice. If air just above the snowpack reaches the dew point, the snowpack can develop hoar, which is a light feathery crystal that does not bond well to snow. If the top of the snowpack freezes and thaws repeatedly, it can develop clusters of frozen particles with space in between, which creates an unstable surface for the next layer of snow. Changes within the snowpack take place due to the temperature gradient, the difference in temperature between the upper and lower layers. The snow near the bottom is relatively warm, close to 0 degrees Celsius or 32 degrees Fahrenheit, because of residual heat from the ground. The temperature in the upper layers depends on the temperature of the air. Snowflakes in the snowpack undergo different types of changes depending on the size of the temperature gradient. In snowpacks with a high temperature gradient, a large difference in temperature, crystals tend to develop facets. The flat surface of a facet cannot bond well to other surfaces. Heavily faceted crystals located deep in the snowpack are called depth hoar and create dangerously instability. On the other hand, solid low temperature gradients and consistent sub-freezing temperatures cause rounding, which allows crystals to compress more tightly. The exchange of water vapor during rounding also creates bridges between crystals and parts of crystals, creating a firm, stable snowpack. Regardless of whether they are the result of temperature gradients, atmospheric conditions during snowfall, or melting and refreezing, strong and weak layers of snow make avalanches possible. Avalanches have three ingredients: snow, a sloped surface, and a trigger. A weak layer within the snowpack, caused by ice, surface or depth hoar, faceted crystals, or graupel also contributes to the process. If the weak layer is near the surface, it causes a slough, a cascade of loose, powdery snow in an inverted V shape down the sides of the mountain. Sloughs are like sand rolling down a dune, and they usually cause minimal damage to property and people. If the weak layer is deeper in the snowpack, it can cause a slab avalanche, which is far more dangerous. In a slab avalanche, a strong, cohesive layer of the snowpack slides down over a bed layer of snow, like thawing snow sliding down a car's windshield. Sometimes the entire snowpack breaks free from the mountain and slides over the ground. The layer of a slab avalanche depends on the properties of the slab and the depth of the weak layer, also called the failure layer. Hard, cohesive slabs create a very large chunk of solid snow, while softer slabs create smaller blocks. Slabs of wet snow cause generally slower avalanches than dry slabs, because they typically hit obstacles with more force. Avalanches usually start on the mountain slopes that are at a 25 to 60 degree angle to the ground. Slopes less than 25 degrees generally can't produce avalanches as they are steep enough, and slopes steeper than 60 degrees usually slough their snow constantly, giving slabs little chance to develop. Most avalanches begin on 35 to 45 degrees slopes. Most slab avalanches take place on leeward rather than windward slopes. They can have a natural trigger, like a sudden change in the weather, a falling tree, or a collapsing cornice, an icy overhang of wind-driven snow near the ridge. In spite of what movies and cartoons depict, the trigger is almost never a loud noise. In most fatal avalanches, people create the trigger. Once they begin, they have three segments: a starting zone, often above the tree line and near the ridge, where the slab breaks away from the rest of the snow; a track, or the course the avalanche follows down the mountain. You often see avalanche tracks even in the summer because of missing trees; a run-out, where the sliding snow and debris eventually comes to a stop. When the snow stops, it compacts and sets up like concrete. This is what makes avalanches so dangerous to skiers, hikers, and snowmobilers. They generally cannot dig themselves out and must wait for rescue. Avalanche fatalities are most common in the winter months, but since early season snowfalls and spring thaws are also dangerous, they can occur in every month of the year. In addition to the threat to human life, avalanches can cause tremendous damage to buildings and property. They can also close roads, cover train tracks, and disrupt local economies. So, ski patrols and other organisations usually take steps to prevent major avalanches. Most countries use a warning system to tell people how likely avalanches are. Lots of parks and resorts have hotlines and web pages with up-to-date information about the area avalanche forecast. One technique to prevent avalanches is to deliberately trigger small, controlled avalanches when no one is on the slope. Staff and researchers first study the snowpack either by digging pits and analysing each layer, or by using radar technology. Then they start an avalanche with explosives or artillery fire. On small test slopes, they may also perform ski checking by deliberately skiing along fracture lines high on the slope. People performing ski checking always work with at least one partner, who remains in a safe location in the event that the skier gets caught in the avalanche. Other techniques involve preventing the conditions that lead to avalanche or interrupting the flow of snow. In some locations, fences, posts, nets, anchors, and windbreaks change the way snow collects, reduce the size of the slab, or provide physical obstacles in the event of an avalanche. Authorities in parts of the United States and Canada have also reforested areas that underwent heavy logging, but avalanches can happen in spite of all preventive measures, especially in the first 24 hours after fast, heavy snowfall. In February 1992, a big-scale avalanche caused many deaths in eastern Turkey, a place that often experiences heavy snow. The snow of 1992 was extra heavy, more than 30 feet of snow in some areas. Large avalanches started to fall from Mount Gabar onto the villages of Gormek, Siernak, and Seysslis. Gormek disappeared under the snow. More than 250 people died. That's more than half the population of Gormek. Snow also engulfed a military post outside the village. It killed 70 out of the 120 people stationed there. The ones that survived joined in the rescue efforts in the village. Medical teams and emergency supplies were flown in from America to Turkey. The Turkish government declared the region a disaster zone as more snow fell and avalanches were a fear. Avalanches are most common on smooth, steep slopes without a lot of obstacles or tree cover. Unfortunately, these are the areas that lots of backcountry enthusiasts like to use for skiing, hiking and snowboarding. Also, some popular activities like high marking, where you drive a snowmobile as high as you can up a steep incline and then arc back down the slope, are exactly the kind of actions that will start an avalanche. This makes avalanches in areas where people are likely to be inevitable. Preventing an avalanche is far easier than surviving one. The most important step to be aware of your surroundings and to monitor weather conditions closely. Thank you for listening.